And now we have part 2 of the examples part of our discussion on optics. In this video, we take a look at 3 more examples, and then we move on to the next part of our discussion in optics in the next video. So consider example number 3. You have the following problem. A curved mirror is used to produce an image of a toy car. So you have an actual object, a toy car. The image has a height of h prime is equal to 0.4 h, where h is the height of the toy car. If the mirror has an absolute value of f equal to 40.0 centimeters, so absolute value of the focal length. So we don't know if the actual f is positive or negative, but we know the absolute value is 40 centimeters. Determine the distance of the toy car from the curved mirror. So determine the object distance. Is the image formed real or virtual? The image of the toy car, is that real or virtual? And finally, what kind of mirror was used? So it's a curved mirror. For a plane mirror, you will recall f is infinite, so it doesn't matter if positive or negative. But this is a curved mirror, meaning the focal length f may be positive or negative. So to determine the kind of curved mirror that was used, we have to determine if f is positive or negative. So h prime, according to the problem, is 0.4 h, and the absolute value of the focal length f is 40 centimeters. First, we use or look at the magnification equation, the lateral magnification. M is equal to h prime over h. M is also equal to negative s prime over s. So focusing on this part of the relationship, h prime over h is equal to negative s prime over s. If we isolate s prime, you have s prime is equal to negative sh prime over h. H prime is 0.4 h. We can cancel out h, leaving us with s prime equal to negative 0.4 s. For the system described by the problem, you have one mirror and one object. This basically translates to object distance being positive. The only possible way that for S to be negative if there's more than one optical element. If there's, say, two mirrors or one mirror and one lens, or if you have two lenses. But since there's only one optical element, the object distance is automatically positive. Since S is positive, that means S prime equal to negative 0.4 S. That means S prime is negative. And if S prime is negative, that means the image that was formed is a virtual image. So is the image formed virtual or real? The image is virtual. Next, we use 1 over S plus 1 over S prime is equal to 1 over F. Isolating F, you have F is equal to S times S prime over S plus S prime. Using S prime is equal to negative 0.4 S, we are able to get that the focal length F is negative 0.6666 and so on S. Since S is positive, positive times negative, that means the focal length is negative. For negative focal length, that means you have a convex mirror, as opposed to concave mirror where the F is focal length is positive. So here, focal length is negative. You have a convex mirror. Finally, what is the distance of the toy car from the curved mirror? F is equal to negative 0.666 and so on. S, isolate S. S is equal to F over negative 0.6666 and so on. Absolute value of F is 40 centimeters. We know now that F is negative, so negative 40 centimeters, the focal length of the mirror. So substituting F with negative 40 divided by negative 0.666, so cancel out the negative sign. 40 divided by 0.666 and so on, we can calculate S, the object distance, to be 60.0 centimeters. The object is 60 centimeters from the from the curved mirror. So you have a virtual image, convex mirror, and object is 60 centimeters from the mirror. Next, we have example number 4. This time we have a lens, in particular a diverging lens of focal length f is equal to negative 60 centimeters. The lens is used to produce images of a praying mantis. First, the lens is placed 1 meter from the praying mantis. There's an image formed. Next, the lens is moved and placed 65 centimeters from the praying mantis. Another image is formed. So we have case 1 and then case 2. Determine the ratio between the heights of the two images that was formed. So height of the image in case 1 and height of the image in case 2, get the ratio between the two. In other words, case 1, H1 prime. Case 2, H2 prime. What is the ratio between H1 prime and H2 prime? So focal length F is equal to negative 60 centimeters or negative 0.6 meters. We have two object distances for the two locations of the lens rather. First case, the lens is placed 1 meter from the praying mantis, so object distance S1 is 1 meter. While in the second case, the lens is placed 65 centimeters from the praying mantis, so S2 is 65 centimeters or 0.65 meters. Using our equation for image formation, 1 over S plus 1 over S prime is equal to 1 over F. We get first case. For the first case, we have 1 over 1 plus 1 over S1 prime is equal to 1 over negative 0.6. We are able to calculate S1 prime. Negative 0.375 meters. Using now the equation for magnification, M1 is equal to H1 prime over H. There's only one object, so H1 is equal to H2. Might as well just use H. M1 is also equal to negative S1 prime over S1. We know S1 prime. We know S1. We can calculate the lateral magnification N1. 0.375 divided by 1 or simply 0.375 meters. No unit rather, di ba? Magnification, height divided by height, cancel out yung unit. So 0.375 yung M. Which means M1 is equal to H1 prime over H. If we transfer H to the other side, we have H1 prime is equal to 0.375 H. We have an equation for H1 prime. If we do the same thing for the second case, we are able to get the equation for H2 prime, 0.48 H. H1 prime, H2 prime, we get the ratio H1 prime divided by H2 prime. We can cancel out H. That leaves us with H1 prime over H2 prime is equal to 0.781. The ratio between the heights of the two images that were formed. And finally, we have example 6. An apple is placed 1 meter in front of a concave mirror. F sub m is 30 centimeters. A converging lens, F sub L, 60 centimeters, is placed between the apple and the lens. The lens forms an image of the apple, and from this image, the mirror forms an image. If the distance between the lens and the mirror is 20 centimeters, determine the distance between the apple and the image formed by the mirror. So here you have a figure. You have the apple and the mirror. Between the two, you have the lens. The lens and the mirror are 0.2 meters apart. First, the lens, the light from the apple will encounter the lens, so the lens will make an image of the apple. First, let's look at our variables. F sub m, zero point 0.3 meters, F sub L, 0.6 meters, and S sub L, SL, object distance between apple and lens. From apple to the mirror is 1 meter. Mirror and lens is 0.2 meters. That means this is our distance SL. SL is just 1 minus 0.2. That will give you 0.8 meters. So this is wrong. This is not centimeters. This should be meters. 1 meter minus 0.2 meters is equal to 0.8 meters. Not 0.8 centimeters, but 0.8 meters. Using now our equation for image formation, 1 over SL plus 1 over S prime L is equal to 1 over FL. We know FL. We know SL. We are able to calculate S prime L. SL prime. 2.4 meters. So again, FL is 0.6 meters. SL is 0.8 meters. Not centimeters, but meters. 0.8 meters. So we are able to get SL prime to be 2.4 meters. Positive. SL prime is positive, meaning for the lens, SL prime is behind the lens. So here is located the image formed by the lens. This image will be the object that is seen by the mirror. Notice that as far as the mirror is concerned, the object is behind the mirror, so object distance should be negative. 2.4 meters lens to the object or this or image or object of M. Lens and mirror is 0.2 meters, so mirror to the object is 0.2 minus 2.4. That will give you negative 2.2 meters. Negative meaning the object is behind the mirror. So using this object distance, knowing F sub m, 0.3 meters, we are able to calculate SM prime 0.264 meters. So from the mirror, a positive. So what does that mean? S prime M is positive. That means the image formed by the mirror is in front of the mirror. So if this is the mirror, in front of the mirror is the image. So this is our final image. This is the object, the apple. The distance from the apple and the final image is distance D. Knowing that the apple and the mirror are 1 meter apart, so 1 meter minus S prime M, SM prime, we are able to get the distance D, 0.736 meters. So that's it for now. We'll continue our discussion on optics in the next video, wherein we take a look at interference and diffraction of light. So thank you for watching.